All right, so let's start talking about some different types of countermeasures. When you have some kind of a threat or a risk and you want to defend against them, one approach is to use prevention. So in prevention, what we're trying to do is we're trying to prevent the bad thing from happening. Okay, make it impossible to steal the item or whatever bad we're worried about. And prevention is great. In some sense, if you can do it, it's like the best you could hope for to completely stop any bad thing from happening. So, for instance, we'll learn about buffer overflow vulnerabilities next week, which are endemic in C and C++ code. Well, if you write in a memory-safe language like Python or Java, it turns out you're just completely immune from buffer overflow exploits. You don't need to worry about them. That class of attack has been prevented. So that's awesome. That's sweet when you can get it. The potential downside to be aware of is, like, if the prevention thing doesn't work and there's some way to defeat it, then you can, if you're not careful, end up with a system that's very brittle. So the classic example of this would be Bitcoin, where Bitcoin is a way you can transfer money and there's no way to reverse it. Okay, so if I write a fraudulent check and that transaction happens, banks actually have a way to reverse the normal financial transactions within a set number of time, 3 to 5 days, something like that. There's a way to undo if it's later discovered to be bogus or fraudulent. But with Bitcoin, there's no way to undo. Once the money's transferred, it's transferred. There's no reversing it. And so there's been a number of high-profile thefts where exchanges, companies that had a large amount of Bitcoin were hacked. And the hackers took over their machine and transferred the Bitcoin to themselves. And once that happens, it's irreversible. The money's gone forever. Okay? So that's the downside of relying on prevention is, yeah.
So for like the example above with like Python and
Mm-hmm.
memory safety,
Yeah.
Is there some sort of like provable way of showing if like Python can't be exploited, or is it just kind of like assumed it's like baked into how it's built?
The way I think of it is it was designed to not have this problem. So the problem arises because of lack of bounds checking. If you do out-of-bounds access to memory, well, Python is designed to automatically do bounds checking everywhere. In C, it's up to the programmer to do their own checks. Python does it for you. Every place where you could ever access memory, before accessing memory, it checks that it's in bounds. So from a programmer's perspective, it's safe kind of by design. Yeah. So that'd be an example of prevention, because the Python designers knew about this problem and said, we're going to prevent it.